Okay, can you hear me? Okay, hello, can you hear me?
Yes, sir.
Okay, okay. So now we'll continue from here. Okay, so basically, this is our process when you want to make the land use and land cover classification map using the Google Earth Engine platform. We follow the process, all of the process. The first process is that we need to collecting. First of all, we need to import our shapefile. Which boundary you want to make LULC map? You can simply import this area. Then you have to choosing and filtering the image collection. It can be Sentinel or it can be Landsat. You can choose your image and filter, and then collecting the training point for every feature or every classes. Okay, then merge all of the training point and make a training data set, and then we can using the training data set we can use the some data for train our model and also some data for checking the validation. Okay, or train our model or check the validation or accuracy. Okay, and then create the classifier. So this is the type of the machine learning. Suppose if you want, you can use the classification and regression trees, or if you want, you can use the another classifier. And Google Earth Engine has a lot of classifier will be available in here. Then create the create classified image and display the result, and then finally you can calculate the area and also check the accuracy of this map. Okay, so in this time I also simply open my code editor and try to show you the practical example so that you can easily understand about this. So I simply open a new code editor. Okay, so in this time, first of all, I simply import my area. Suppose I want to make the land use and land cover classification map for the region of Dhaka city. Okay, so first of all, which area you want to make for land use and land cover classification map, you can simply import the area. So in this time, so here I already import my area for the Dhaka city shapefile. I simply import this shapefile and then I work with this. Okay, so I simply click to the import. Okay, so now import my shapefile in here. In this time I also need to I simply change the name. Suppose this name is that my RY or region of interest. For this region I want to make the LULC map. So in this time I simply go to my browse data catalog. Suppose in this time I want to use the Landsat 8 imagery. You can use any satellite imagery, all of the things will be same. So I simply use the Landsat. Suppose I want to use here the Landsat 8. And then suppose I want to, you can see a lot of images. Surface reflectance, if you want, you can use the surface reflectance. If you want top of atmospheric or raw image. Okay, so in this time I want to use the top of atmospheric image. This image collection I want to use for making the LULC map. So first of all I need to import the image collection. So for this I simply just copy this Earth Engine snippet from here and then simply paste in my code editor, and then I simply just give a variable name. Suppose this variable name, I simply put the variable name L8. Okay, so I can say I simply import my image collection. In this time I want to just filter this image collection and I want to get my image, and I also from this image I want to take the training point. Okay, so for this, in this time I simply use here I simply use a function. Suppose this, I simply use a variable name. Suppose this variable name is the image. Okay, then I simply call my full image collection, and full image collection is stored in this variable L8. I simply call the L8 and I want to filter this L8 according to my region. So I simply use here the filter bounds function, and then I simply put here my region variable name is that RY. Okay, and then I simply use here the another function filter date function. Suppose I want to make the LULC map for the year of 2020. Okay, so I simply use here the time, suppose 2020 1st January, and then I simply put here the year of 2020 December 31. Okay, and suppose I want to filter the image properties. Suppose image specific image properties, I want to need only for this image which image will be not more than 1% cloud cover. I simply use here the filter metadata function, and then I simply use here the image properties, and image property name is the cloud cover, and I want to set the value is the less than 1. Okay, so in this time here you can see here I can get how many images I want to get. I want to check it. I simply use the print function and use here the image and use here the size and size. Okay, size function, then click to the run. So here I can get, you can see total 7 images for my region for year of 2020. Okay, and if you want to check the all of the images specific date or time period, you can simply use here the image and then simply just use here the print this image. Then I can get all of the information about this total 7 images, all of the acquisition date, all of the things I want to get, you can see. So I simply click to here and go to the feature. So here I can get all of the total 7 images I want to get from here. So in this time here you can see, if you want to make the LULC map every single image, suppose I want to use the LULC map for this first image, you can see what is the date for the first image. We can get the first image date is that year of 2020 11th February. I want to use this image when and want to make the land use land cover classification map. Then you can simply just in here, then simply just copy this ID. And previous class I also tried to discuss about that how we can easily show the single image. Okay, just you can simply just show the single image. Suppose I take the variable name is that suppose image. Okay, and then simply use here the ee.image and then simply paste this ID. Okay, then when I want to use here the map.addLayer function, then I want to show the for only for a specific single date image I want to show in my map. Okay, and then I can easily get the training point from this image and make the land use and land cover classification map. Okay, so it's also possible. Suppose you want to need any specific date images for making the land use and land cover classification map, then you can simply copy this ID and then make the land use and land cover classification map. Okay, but in this time I want to create the median composite and then try to make the image. Okay, so I simply use here the median and it also clip with my shapefile. Okay, my shapefile variable name is that ROI. In this time I want to show the result in my map. I simply use here the map.addLayer function and then simply call my object is the image, then click to the run. You can see a new layer will be okay. So so in this time it not work. Okay, so now you can see it one layer will be added here, but I did not see my image because I also need to focusing the center of this shapefile. I simply use here the map.center object and then I simply call my object. In this time my ROI, I want to focusing the center of the shapefile and shapefile variable name is that ROI. I simply use here the ROI and then use here the zoom level suppose 10, then click to the run. So now I can get the image of satellite image for the Dhaka city year of 2021. Okay, so this is my satellite image, but this satellite image is look like because this is a default visualization. Suppose in this time I want to add here the true color composite or RGB color. So I simply set the band in here, simply click here and set the band. Suppose I want to select the band for the red band, then green band and also blue band. Also increase the state suppose 98% for better looking of the natural color. Okay, then click to the apply. In this time you can see I can get the natural color of this map satellite images. Okay, so in this time you can see I simply import. When I click to the import, this visualization parameter is imported in my code. Okay, so I simply click to the import, you can see it will be imported and we already know about that after the object name. When I want to use here the map.addLayer function, this is my object name. After the object name we always put the visualization variable name and then we always put the layer name. Let's suppose I simply put the layer name is the true color. Okay, then click to the run. So in this time you can see this visualization, this natural color visualization is set with my satellite images. Okay, you can see I can get the satellite images, and now I want to use this satellite image for making my LULC map. So in this time you can say I can get the satellite images, and in this time from the satellite images I need to collect some training point. Okay, if you have own ground truth data, so mainly when you want to make the cropland classification map, then we also need to the ground truth data, and you can easily ground truth data using the GPS or other thing, collect the ground truth specific latitude and longitude you can collect. And you also make the point shape file for every ground truth data. You can make the point shape file. You can easily do it using the ArcMap software. For from the CSV file format, you can suppose your CSV file format has the lat long, you can easily convert this as a point shape file in ArcMap software. Okay, then you can simply import this point shape file as a training point. Then you can also run your model using the ground truth data. Okay, so in this time I have not any ground truth data for this, so I simply take my training point from this satellite images. Okay, so mainly we can use the different types of band combination for you collecting the some training points. So in this time here you can see this image is look like the natural color. Okay, or human eyes what can see. Okay, so this is the natural color. So when you use the RGB color or red, green, blue band, then we can get the natural color. Or a lot of band combination will be available for identify the different types of feature. Okay, so I also try to show you that all of the band combination. So in this time here you can see I want to in this time my first process, my first step is and second step is done. Okay, in this time I move to the third step. My third step is that I need to collect some training point. Okay, so when I want to collect the training point, I can simply take the marker. You can see marker. So this marker I want to take the training point. If you want, you can also use here the rectangle or other things. So training point means that I want to collect the some specific band value for every classes and make the training data set, or a spectral signature I want to collect from the satellite images and make a training data set for every class. Okay, so first of all I want to collect the some training point for the water. So I simply click on here, you can see marker, simply click to here, and then you can see a new geometry will be added here. Also you can see geometry also added here. So in this time I simply click to the properties, edit layer properties in here, and then suppose in this time first of I want to take the training point for the water body. So I can simply put the name is the water as a variable, water. You can put any variable name, water. Then I simply use here the feature collection, import as feature collection, and then property. So in this time property name is the same for all of the classes. When you want to take the vegetation training point, you can use the same property name. When you want to take the build up training point, you use the same property name. Okay, property name is the same. So in this time I simply put the property name is the class. You can use any name. I simply put the class. Then value. In this time for all of the training point I want to set the value is the 0. Okay, I set the value is the 0. So in this time all of the training point for the water, when I take the training point is you can see this is the water body. I simply easily identify this is the water body. Okay, I simply take the water body training point. You can see every single training point for the water body, this value I set the 0. Okay, so all of the training point water body, when I can see in my data, when I create the data set, and in this data set when I see this is the 0, I mean that this is the water training point. Okay, so I simply take the training point for the water body. So water body training I take the some. Okay, okay, I take the training point water body. So in this time I want to check the, suppose in this time I want to take the training point for the build up area. Okay, so I simply click to here, and then you can see new geometry will be added here, and then simply click on the edit layer properties and put the value is that, suppose I put the value is that, suppose build up. Okay, build up, and then click to the imported feature collection, and then property name is the same, class, and value in this time I set the value is the 1. So all of the training point I want, when I want to take the training point, then it when I want to show this value is the 1, I can easily identify this is the training point for the build up area. So I simply click to the OK, and then I simply take the training point for the build up area. Okay. So in this time you can see here I use only for the one band combination. Suppose you want to make the land use and land cover classification for unknown place. Okay, totally unknown place. You don't know what is the feature. Then we also need to use here the different types of band combination for identify the specific feature. Okay, so in this time I also try to show you this. Suppose okay, so I take the some training point for the build up area. Suppose in this time I want to take the training point for the vegetation. Okay, I simply click to here and then I simply just click to here and then put the name, suppose vegetation, and then imported feature collection and property name is the same for the class, and value is that in this time 0 1 and this is a 2. Okay, then click to okay. Say okay, so just a minute, then click to okay. Okay, the vegetation in this time, suppose I did not easily recognize where the feature I can get the vegetation, so then I also change the band combination, and you can see I simply show you the website. This website is the Lancet. Just a minute, Lancet. Okay, so this is the website for Lancet 8 band combination. So mainly we can use the different types of band combination. You can easily go to this link and website and gisgeographer.com, and you can easily find out this article, and you can write this article, then you can easily get a lot of information about the band combination. So in this time you can see this is a natural color. When you want to use the band combination for the red, green and blue, then we can easily identify the healthy vegetation is the green, unhealthy flora is brown, urban feature appear to white and gray, and water is the dark blue or black. And also you can see when you use this band combination for the near infrared band, red band and green band or 543, then it showing the result as a mainly this is the best for the identify the vegetation, analyzing the vegetation. So in this time here you can see the red area, this red pixel value is identify the better vegetation. Okay, and also you can see shortwave infrared. So when you use this, then also you can see what the feature you want to look. When you want to identify the agriculture field or agriculture land, then you can use this band combination 652. Okay, also you can see geology. When you want to identify any geological structure, then you can easily use this bathymetric. Okay, so lot of indices will be available. Also in the vegetation index, so mainly we use the vegetation index for identify the vegetation. So in this time, suppose I want to use this band combination and identify what is the vegetation, so I can simply use 543. So I simply go to my image information, image, and then go to the layer and then click to here, and then I simply set the 543. So I simply click to here and then 5, then 4 and then 3. Okay, then suppose 98%, and then click to the apply. So in this time you can see red pixel value where you can get the dark red, more red, that it's identify the vegetation. So I simply select the vegetation. I can easily identify this is the vegetation. I simply select collect the training point from here. Okay, so this is the red. So I simply take the training point from this red, and this is the vegetation. Okay, so I take the vegetation. In this time, suppose I want to take the another layer for training, take the barren land. Okay, so I simply take the new layer and then click to here. Then you simply use here the barren land. Then click to the feature collection and import as property name is the class and value set the suppose in this time 3. Okay, so in this time I want to take the some barren land in here. So if you want, you can also use there the barren land index or BI index. Okay, so you can easily find out the equation of the BI. Then you can easily apply this equation and you can easily identify. So previous class we also try to show you that for how you can easily showing the NDVI. So this same way, just you can put the barren land index, then you can easily identify the barren land. Okay, so in this time, suppose I want to just go to my natural color. So I simply use here the B4, B3 and B2, 98%, and click to the apply. And so I simply take the barren land from here. Okay. So in this time, you can see I take the training point for the water body, build up, vegetation, and barren land. So I want to classify.
I have a question.
Yeah.
In some area, there were residential area or industrial zone mixed. So how can I distinguish between if I want to show residential area one layer and industrial area one layer?
So mainly then we also need to training point. Okay, so basically when you want to suppose when you want to make the cropland classification, and in this time when you want to make the land use land cover classification, then it will be chance to mixing the pixel value. Okay, for residential area and industrial area pixel value mixing with each other, but we ignore this part using the ground truth data. Okay, actually what is the ground truth data? When you want to put the ground truth training point, and then we can easily run. So mainly when you want to use, we can use the same method for when you want to make the land use cropland classification. So all of the crop, suppose the different types of crop, the this is the NDVI value is the total, almost same. Okay, then we can use the ground truth data and identify this is the specific crop NDVI, this is the specific crop NDVI, then this is the specific crop band value. Okay, then we can easily make the differentiate. Okay, using the ground truth data. Yeah.
মানে ধরেন আমি জানি যে এখানে আমার রেসিডেন্সিয়াল জোন আছে, পাশে হচ্ছে আমার হচ্ছে ইন্ডাস্ট্রিয়াল জোন আছে, তো আমি দুটাকে আলাদাভাবে কিভাবে দেখাবো? আমি ম্যাপ দেখে বুঝতেছি যে এটা রেসিডেন্সিয়াল আর এটা ইন্ডাস্ট্রিয়াল।
Then you can get the training point from the residential and industrial area, then you can also classify. Okay, but it has some chance to mixing with the pixel value with the industrial, because this is a totally built up area. Okay,
এটা আমি যখন করছিলাম না আমার অনেক সমস্যা ফেস করছি, যে আমি আলাদা করতে পারতেছিলাম না যে কোনটা বাসা দেখাবো আর কোনটা ইন্ডাস্ট্রিয়াল জোন দেখাবো।
Okay, so it's also possible. So then we also need to take the more training points, so you can check the accuracy. Okay, so you can also check the accuracy, what the accuracy you can get. If you can get the low accuracy, then you also need to increase the training point for the both of the classes. Okay, then also need to check, and it's also depend on your machine learning method. Suppose what types of machine learning methods are you using in here, random forest or other?
Bhai, I had a question.
Yeah.
Can I ask in Bangla?
Okay, no problem.
আমি হচ্ছে ওই যে আপনি যে অ্যাপগুলো দেখাইছিলেন সেখানে দেখছি যে একটা সারা বাংলাদেশের আপনি হচ্ছে একটা এরকম LULC ম্যাপ বানাইছেন এবং ওখানে অনেকগুলা ক্লাস ছিল। আপনি কি মানে সবগুলা মানে পুরো বাংলাদেশের এরকম ম্যাপের জন্য কি আপনি এরকম জিওগ্রাফিক পয়েন্ট নিয়ে নিয়ে কোথায় কি আছে সেটা করছিলেন, নাকি আপনি মানে এরকম এই প্রসেসে মানে চোখের আন্দাজে দেখে দেখে করছিলেন?
হ্যাঁ, না এখান ক্ষেত্রে বাংলাদেশের ক্ষেত্রে তো পুরোটাই ট্রেনিং পয়েন্ট বা কালেক্ট করা সম্ভব না। এই ক্ষেত্রে আমরা করি কি, আমরা একটা যেমন ইতিমধ্যে সেন্টিনাল যে ইমেজারি আছে সেন্টিনাল 2 আমরা একটা রেফারেন্স ইমেজ ধরে নেই। সাপোজ যেমন সেন্টিনাল 2 বা মডিস যেটা আছে, যেমন আপনি যদি দেখেন সেন্টিনাল 2 just a minute, Sentinel-2, then we take the some reference satellite images. Suppose we already take the some images. Suppose Sentinel-2, you can see this is the world land. They also in the recent time they also make the data set for a dynamic world. So you can see, suppose you can see this is the automatic, this is automatic data set for the whole world. Okay, so in this time when you want to make the whole country boundary for any Bangladesh, then we can also use this data set as a reference training point and then make our model, or also do for the modis. So recently this data set we can get, and we can easily identify the water, trees, grass, flooded vegetation, crops. Okay, build up area, bare, snow and ice and level, we can easily identify. Okay, from using this data set, then we don't need to take the training point. Okay, we can take the reference data set like this. So reference data set, I want to take this data set as a reference data set, and then we can take the training point using this reference data set. Okay, when you want to take the whole country boundary.
আচ্ছা, আমার আরেকটা কোশ্চেন আছে, আমি কি এখান থেকে কিলোমিটার বা 10 কিলোমিটারের সার্কেল এঁকে দেখাতে পারবো?
Circle means?
হ্যালো,
Yeah, I hear you.
মানে ধরুন আমি আমার একটা প্রজেক্টের এরিয়া থেকে 10 কিলোমিটারের জাস্ট LULC ম্যাপটা করতে চাচ্ছি পুরো ডিভিশনের না পসিবল?
Yeah, possible. So then we also need to suppose we can create the buffer. So we can easily create the buffer and then we can put the buffer circle. So how many radius you want to need? Okay, so you can simply create the buffer and create the circle and then we create the easily make the LULC map from the circle.
একটু দেখা দিলে ভালো হয়।
Okay, so we complete our this first of all we complete our class, then we also try to discuss. Okay, for the how you can easily create the buffer, you can simply search your buffer. Suppose you can see also try to search the function. Suppose buffer, you can see buffer. So buffer, this is the function. Suppose you can simply select the distance. Okay, so distance, then you can easily get the area for 10 kilometer distance radius like this. Okay, so so in this time here you can see, and there is a lot of way when you want to make the land use and land cover classification map. It has a lot of way. Okay, so basically in this time these are totally introductory parts, so that's why I will not go in the depth of land use and land cover classification map. Basically we have the another advanced course for only for the land use and land cover classification. In this course we will also try to discuss all of the machine learning method. Okay, suppose all of the machine learning method, all of the equation, how it will be create this equation, all of the things we will create it. But in this time I also try to show you only for the beginners level. Okay, so how you can easily make the any normal LULC map. Okay, and this is the same process when you want to apply any small region like this, then it will be better. Okay, so in this time I also, you can say I take the training point. In this time I get the training point and then I need to make the merge all of the training point together. I need to merge all of the training point. So for this, when I want to merge, I simply use the merge function. So I simply take a variable in here. Suppose I simply take the variable. Suppose this variable name is that training. Okay, then I simply merge all of the training point together. So I simply call the water. Then I simply use here the merge function, merge with built up area, and it also merge with vegetation. It also merge with Berlin. So I merge. In this time I want to check what is the condition of my training point, all of the training point. I simply print this and then simply check it. Just simply copy the training and paste here and then click to the run. So now you can see how many I can get. Total 133 training point for all of the classes. Okay, water body, build up, vegetation, Berlin. In this time you can check it. I simply go to the feature and you can see, suppose this I don't know what is the training point for classes. So I simply click to here. Here you can see the properties. Simply click property, you can see one. So I can from the one I can easily identify this the training point is for build up area. Okay, so we classified all of the we can just take the all of the training point. Total I can get total 133. In this time for the total 133 training point, I want to need some band value. Okay, so in this time I select the some band. So I simply take a variable. Suppose this variable name is the bands, and then I simply put the suppose B1 band, B2 band, B3 band, suppose also red band B4, near infrared band B5, B6, sorry, B6, B7. Okay, so I simply take this all of the band. In this time all of the band value I want to need. for every single training point. Okay, so every single training point I want to need all of the band value. Suppose B1, this band value I want to need for all of the image. For you can see this is a single point, this single training point I want to need all of the band value. Okay, and I want to create the training data set. Okay, so in this time I just simply take my input. Okay, so I simply, you can see these bands, this band is not add with my image. So my image is that, you can see this is my image, but I want to separate some band, but this image has the total 17 bands. From the 17 bands I want to select some specific band. In this time I want to just need to add this band. I simply take the variable input and then I simply call the bands. Okay, and then paste, sorry, I simply call the image. Okay, image, and then I simply paste here and use here the select function, and I just select the bands. Okay, because this list is stored all of the band in this variable, and paste here. Okay, so in this time this is my input. I want to use this input for train my model. Okay, so in this time I want to create the training data set. Okay, so training data set means that I want to create the spectral signature for every single point for all, using all of the bands values. So for this I simply just take a variable. I take the variable and give the variable name is suppose train image. Okay, and then I simply call my input. Okay, because my input has stored the image and a specific band. Okay, I simply call the input and then I simply use a function sample regions. So mainly sample regions is a function, it generates the spectral signature or band value. Okay, so in this time you can see I can get all of the argument. I simply put all of the argument one by one. So I make a dictionary in here, it's curly bracket start and curly bracket int. Okay, in this time collection, you can see collection. So collection is that in this time this is the keyword and key value is that my training point, all of the training point. You can see all of the training point is stored in this variable training. I simply copy this variable name and paste here. Okay, then another argument keyword is that properties. So properties is that when I want to take the properties, you can see I want to just properties, you can see what is my properties name is the class. Okay, property is the same for all of the training point. Okay, so I simply use here the class. Okay, then level scale. Scale is the resolution of your satellite imagery. So in this time this is the Landsat 30 meter. Okay, so for then I simply remove all of the things from here.
Why you have put third bracket on plus?
Because in this time this is the list. You can see here I want to water, it has also class, this build up also class, this vegetation is also class, barren land is also class, all of the property is the same. Okay, so that's why we can simply just as a list I can simply use here the square bracket. Okay, because all of the properties is the same. Okay, all of the classes. Okay, and scale is the 30 meter. In this time I want to check my result, and for this I simply just print this. So I simply print and then I simply call the train image and just paste here and click to the run. So in this time I can get all of the spectral signature value or band value for every point. So you can see, so I simply click to here and click on the feature. Suppose you can see for the 0, for this point I want to check my all of the band value. So I can simply, you can see I can get all of the band value for the class 0. Okay, so I created that all of the point, every single point I created the all of the band value, all of the bands, so which band I want to input in here. Okay, so every single point, every single point, every single point, you can see every single point. In this time if you want you can also add some external band. Suppose when you want to more accuracy or when you want to more accurate LULC map, then we also try to add here some external band. So mainly external band is help you to make the correct LULC map. So suppose you can see sometime when you want to make the LULC map, then this mixing pixel value will be mixing with each other. Okay, suppose the barren land and build up area, this spectral signature value is almost same, so then it also mixing with each other. Then if you want you can also use the two types of index, suppose barren land index and build up index. and then you can also input here. Then you also get the band value for the barren land index, as well as also get the build up index band value. Okay, then you can also, then it's also more better. Okay, sometimes you also see the vegetation and water, this pixel value also mixing with each other. Then you can also use here the NDVI. You can create the another external bit for NDVI, as well as you can also use here the another band for the NDWI. Then this all of the training point also created the value for the NDVI as well as also NDVI. Then we also get the more accurate map. So in this time, this is the introductory part, so that's why I will not go the any other advanced topic. So that's why I simply normally make the LULC map using the which band already exists in my satellite image. I want to use this band. Okay, so in this time here you can see I just create my data set. Okay, so this is my data set. This data set means that all of the pixel value, all of the band pixel value I want to create for every single point. Okay, so in this time I want to just create my, from this data set I want to, suppose I want to use here the 80% data for train my model and 20% data for checking my validation. What is the accuracy of this map? I want to check it. Okay, so for this, in this time I want to take the randomly this data set, and for 80% data for train my model and 20% data for test my model. Okay, so for this I simply take a variable. Suppose this variable name is the train data. Okay, in train data variable I simply call the train image, because this variable is stored all of the data set, all of the pixel value signature is stored. So I simply copy and then simply paste here. Okay, in this time you can see I simply use a function. This function is called the random column, because in this time I want to take the 80% data and 20% data randomly, not selectively. Suppose you can see total 133 training point. From this I take the 80% data for train my model and 20% data for test my model. But in this time I want to take the training data and testing data randomly, not selectively. Okay, so in this time, so that's I simply use the random column function, and then you can see it will be stored in the train data. So in this time this train data is separate, the two way, test my model and train my model. Okay, so I simply take a variable. Suppose this variable name is that train set. Okay, this set of data I want to use for train my model. Okay, so I simply take the train data. Okay, so this train data, just train data. Okay, then I simply just copy this variable name and paste here. In this time I just simply use here the filter function. Filter, I want to filter ee dot filter, then less than, then I simply use here the random 0.8. Okay, and do I take the another variable. Suppose this variable is that I can simply put the variable name is that test set, and then I simply call my train data and paste here, and use here the just simply use here the filter, then ee dot filter. In this time I use here the greater than or equals so function, so I can simply use here the greater than or equals, then randomly 80%, sorry, 8. Okay, so in this time here you can see, in this time I just divided my data set. For that whole of data set it will be stored in this variable. I simply divided the two way.
Is it 0.8 or 0.2? Can set?
So it will be 0.8, because here I use the greater than or equals. So first of all you can see less than. Okay, so randomly less than, and then I also use here the greater than or equals. Okay, so it separate the roughly 80% training data and 20% testing data and store it in this variable. Okay, so in this time I just use this variable for train my model, because this variable are stored 80% data and this variable is the storage for the 20% data. Okay, in this time I just separate this. In this time I need to create the classifier model or machine learning model. So here you can see a lot of classifier will be available here, and every classifier is the better for every specific classification. Okay, you can see decision tree, support vector machine, minimum distance, classification, regression trees, random forest, all of the classifier, spectral regions. Okay, so all of the classifier is important. So in this time I will not discuss all of the classifier. So in this time I normally use this classification and regression trees. So basically this data set, when you use the data set, it automatically created the max nodes, mean leap population, and this is the all of the statistical part. So machine learning different types of argument. Okay, so in this time I will not discuss all of the things, what is the max node, what is the mean leap. Also you can see when you use the support vector machine, different what is the type of support vector machine, what is the kernel. Okay, you can see decision procedure. Okay, a lot of things we will discuss when you want to. Also you can see different types of equation. Okay, so you can say RBF, kernel type. Okay, so a lot of process also need. But if you want to interest to learn the more things about the machine learning using the Google Earth Engine platform, then you can also join our another advanced courses. So in this time I simply use the one classifier. This classifier is the small part. This is the classifier regression. I simply copy this, just copy. Okay, and then I want to use this classifier for classify my image, satellite image. So for this I simply just paste here. I just paste here. Okay, then I simply take a variable in here. Suppose this variable name is that, I can simply use the variable name is that classifier. You can use any name. I simply use here the classifier. Okay, and store in this here. Okay, and you can see when I use this variable and I did not add any argument, it default showing null. Okay, you can see when max nodes I did, suppose you can see what is the max node, maximum node of leap in a node. And we also know about the node. Node is very important type in machine learning. So you can leap node. Okay, leap node is the final output of this trees or decision trees. Okay, so a lot of things about this. Suppose when you want to use the default, so it showing the null. Okay, and also you can see when you use the mean leap in without any default, it's default showing the 1. Okay, so in this time I simply remove all of the things. I want to create the empty machine learning method, or using the classification and regression trees. In this time I just simply put my classification and regression trees, this function. In this time I want to just use here train my model. Okay, so I simply use here the train function. So train, and I want to use the data set for the 80% data set. I simply, you can see I can get all of the argument, and I fulfill all of the argument one by one. So I simply make a dictionary in here, start, curly bracket start, and curly bracket in part. You can see curly bracket int. Okay, then first of all feature is that in this time feature is that my this train set which stored the total 80% data. I simply paste here. Okay, then class property. So class property is that class property is the, I can simply put the class property name. Class property is the class. Okay, in this time you can see first of all when I want to use here the class, I use here the square bracket, but in this time I did not use here. You can see this is the plural properties. Okay, so it had a lot of things. Okay, but in this time here only for the class property. Okay, so that's why I did not use the square bracket. Okay, then input properties is in this time I want to use the input properties is the band. You can see all of the band will be stored in a variable. I simply call the bands this variable name and paste here. Okay, and then I simply remove all of the things if not needed for this time. Okay, so in this time you can see this is my classification regression trees machine learning function. I want to just train my data set, 80% data set, using this function, and all of the things is stored in this variable classifier. Okay, so in this time I want to just add this classifier with my image. My image is that this is my image, and this image is stored in a variable. This variable name is the input. You can see image and a specific band, it is stored in the input. So in this time I just add this classifier with my input, then it will be classified. Okay, so in this time I simply take a variable Suppose I simply put the variable name is that classified. Suppose classified. Okay. Then I simply call my input. So this is my input. I simply call the input. Now I want to add the input with my classifier. So when you want to add the classifier with your input image, then we need to use a function. This function is the classify. Then I simply call my classifier because this variable is stored my machine learning method. Okay, so I simply copy the variable name and paste here. Okay, so now my classified image is created and stored in this variable. So I simply show the result of classified image. I simply use the map.add layer, and then I simply call the classified. This is my object. I want to show the result. Okay, so in this time I just simply show that I want to show, suppose mean. I add the visualization. So mean, it will be start from the 0 because when I want to take the water, I will put here the 0. So I simply use here the 0 and then also use here the max. Suppose max is that you can see, when I last is that you can see this is the 3. So I simply put here the 3. And I also want to define some color plated function, and I make a list of the color plated. So I want to show the 0 is that water. I want to show the water as a blue color. I simply use the blue. Then I also want to show the then 1 0 then 1 is the build up. I simply use here the build up is the red color. Then build up, then also you can see 2 is the vegetation. I show the vegetation is that green color. So then I also want to show here the suppose barren land is the yellow color. Okay, so I want to set this. Okay, so let's go. In this time I simply click to the run. So then we can get the classified image. Then we also try to check the accuracy. What is the accuracy of this model for the classification regression trees? We want to check the accuracy. Okay, so now we can get the classified image. Okay, so you can see, we can easily understand about that. Satellite image is that you can see classified image. It's showing the lot of water bodies, you can see. Okay, so showing the lot of water bodies. So I want to check the where is the water body. Okay, so I want to take the water body from here. Then build up area you can see. Then vegetation, so very less vegetation, and barren land is showing as a yellow color. Okay, so now I don't know what is the accuracy of this map. So I want to check it, what is the accuracy of this map. Then I will, when I can get the low accuracy, then we also need to rearrange the training point. Okay, then we also need the training point also increase or decrease, then also work. So in this time I want to check the accuracy. Okay, so for the when you want to check the accuracy, in this time we use here the rest of 20% data. Okay, so for this I simply in this time we can use the different method for calculating the accuracies, but in this time I want to create the confusion matrix table or error matrix table. From this confusion matrix table I want to just calculate the accuracy, overall accuracy of this map. Okay, so for this I simply take a variable. Suppose this variable name is that I can put the variable name is the confusion matrix. Okay, so in this time if you have any question in here, you can ask me, anyone, any question about this, any question or any doubt?
Good evening, sir.
Yeah,
Sir, yesterday, sir, while doing the boundary of the country, sir, have you already downloaded the shapefile, or you have created the shapefile?
So boundary shapefile you can get from the USDOS web data set. Boundary shapefile you can get this from here. Then you can simply import the shapefile and work with this.
Okay, sir, thank you, sir.
Suppose you can see this is the data set USDOS, and first class I also try to discuss about that how can easily filter the country boundary shapefile. Okay, then you can simply import this and you can easily get the boundary, and then you can easily, or if you want, you can also export the boundary shapefile and work with this, no problem. Okay, and we also already covered the part how you can easily import. Okay,